You know, in system design, it's so easy to get caught up chasing the big, complex problems. But what if the real secret to building amazing systems lies in the stuff we think we already know? Let's dig into why the ground beneath our feet is actually the most important part of any structure we build.
I mean, this quote just nails it, right? It's such a perfect metaphor because it's 100% true. We're all out here trying to build these incredible skyscrapers, these massive, scalable systems. But none of that is even possible without a deep, rock-solid understanding of the foundation.
And that really brings the question right to you. When you're designing something, how confident are you in its foundation? Do you really get the core mechanics of the web that everything else depends on? It's a tough question, but it's one we've got to ask ourselves.
Because, look, when we ignore that stuff, we run straight into a classic trap, the shaky foundation problem. It's so easy to fall into, and it can completely sabotage even the most brilliant designs.
And here is the classic trade-off we see all the time. On one side, you've got the shiny, exciting topics like sharding or consistent hashing. That's the glittering castle. But on the other side, you've got the bedrock. How does HTTP actually work? How does DNS resolve an address? Without that bedrock, that glittering castle is basically built on sand. It's just not going to last.
So here's the big mental shift we need to make. The web isn't just some network for browsers anymore. You have to think of it as the actual operating system for pretty much every distributed application we built. Your microservices, your mobile apps, they all live, breathe, and die on this OS.
All right, let's dive into our first big pillar, performance and speed. And this isn't just about writing snappy code. It's about literally fighting against the laws of physics. The good news is the web itself gives us all the tools we need to win that fight. And these are the real weapons in our arsenal. Things like caching headers, CDNs, and compression, these aren't just little add-ons. They are fundamental parts of the web protocols. And mastering them, that's the difference between a user halfway across the world having a laggy, awful experience and one that feels totally instant.
And this is the enemy we're always up against, network latency. It's the hard speed limit imposed by physics. Your most elegant algorithm in the world can't make light travel faster through a fiber optic cable. But a well-placed CDN, it can dramatically shorten the distance the data has to travel in the first place. That's huge.
Okay, moving on to our second pillar, which tackles two absolute giants, scale and security. And, as it turns out, the web's foundational concepts are completely critical for handling both massive amounts of traffic and keeping your system safe from threats. Seriously, just think of these things as the traffic cops of the entire web. DNS isn't just a phone book for websites. If you're using something like GeoDNS, it's your very first line of defense for load balancing, sending users to the data center that's closest to them. Then your load balancers act as gatekeepers, making sure no single server gets slammed. These aren't just utilities, they are the heart of a scalable architecture. And then on the security side of things, we have stuff like the TLS handshake. Every single secure connection on the web starts with this little dance. As an architect, you have to get this, because encryption always adds a little bit of latency. Knowing how it works helps you make really smart decisions, like where to terminate your SSL to get the perfect balance of security and performance.
And then, of course, there's authentication. The choice between using old-school stateful sessions with cookies versus modern stateless JWTs. That's a massive, fundamental web architecture decision. One choice keeps user data on your server, which can impact how you scale. The other pushes it to the client, which has its own security things to worry about. This decision echoes through your entire system.
All right, our third and final pillar, design and debugging. This is where a really deep understanding of the web lets you build cleaner, better APIs, and, just as importantly, helps you figure out what the heck is going on when things inevitably break.
You know, a great system designer is like a master craftsman. They know exactly which tool to pull out of the toolbox. Building a public API that needs to be cached? REST is your best friend, giving your front-end team total flexibility to ask for the data they need. GraphQL is amazing for that. Need blazing fast communication between your internal microservices. gRPC is an absolute beast. Knowing when to use which is just fundamental.
And this is where the rubber really meets the road, especially when something breaks. When a user says the site is slow, a great engineer doesn't just see a black box. They see a whole chain of events. They start running down a mental checklist. Is it a DNS problem? Is the SSL handshake taking too long? Is it a slow database query? Or is it all the way at the end with the browser trying to render the page? That holistic view is everything for debugging. And let's be blunt for a second. This knowledge is directly tied to your career. If you're in a system design interview and they ask you to design a global service and you forget to mention a CDN, whoa, that's a huge red flag. It shows a gap in your understanding of the fundamentals. It's really that important.
Okay, so let's wrap this all up. We've talked about the dangers of having a shaky foundation. Now let's just quickly recap what it means to build on solid ground, using the web's core ideas as our bedrock.
First up, you've got to remember that protocols like HTTP and TCP, that's the language your systems are speaking. To build anything that talks over the internet, you have to be fluent. There's no way around it.
And second, performance isn't just some cherry on top. It's not an afterthought. It's engineered right from the start using the web's built-in power-ups, smart caching, and a global content delivery network.
And finally, when you need to scale to handle millions or even billions of users, you don't get there by accident. You get there by strategically using the web's own traffic management systems, DNS and load balancers, to make that kind of scale possible.
So really, it all boils down to this. It's a simple idea, but it's incredibly powerful. If you truly, deeply master the foundational principles of the web, you'll have everything you need to master system design itself.
So, I'm going to leave you with this question to chew on. Now that you see just how vital all this is, what's the one foundational topic you're going to really dive deep on next? Is it going to be HTTP/2, DNS internals, advanced caching strategies? The choice is yours, and it's the very first step to building your next skyscraper on solid rock.